Hi everyone, welcome to my channel. In today's video, we are going to talk about matrix arithmetics, including addition, subtraction, scalar multiplication, and matrices multiplication. We will talk about addition and subtraction first because they are easy and apparent. Look at this example. To add the two matrices, we only need to add the numbers at the same entry in the two matrices. For example, we add 1 in the first matrix with 5 in the second matrix, as they are both located at the first row and first column. Hence, we get 6 as the first row, first column entry of the result matrix. Following this rule, we can calculate the other entries and thus the final result matrix. It's easy, isn't it? Matrices subtraction follows exactly the same rule, except we do subtraction instead of adding in the same process. Following this rule, we can easily tell that matrices addition and subtraction can be only performed when the two matrices have the same number of rows and columns. Thus, the example shown in this page is undefined. Scalar multiplication of matrix is simple as well. We just need to multiply the scalar to every entry in the matrix to get the result, as shown by this example. Matrices multiplication is relatively more complicated. In order to understand the concept step by step, let's take a look at this example first. To multiply the 3 by 2 matrix to the 2 by 3 matrix, it's calculated in the following manner. To get the first row, first column entry of the result, firstly, we need to calculate the result of multiplying the first row, first column entry of the 3 by 2 matrix and the first column, first row entry of the 2 by 3 matrix, as well as the result of multiplying the first row, second column entry of the 3 by 2 matrix and the first column, second row entry of the 2 by 3 matrix. Then we add the two results together to get the first row, first column entry of the result matrix. This process is called the dot product of the first row vector of the 3 by 2 matrix with the first column vector of the 2 by 3 matrix. Similarly, the first row, second column entry of the result matrix is the dot product of the first row vector of the first matrix with the second column vector of the second matrix. Repeating the same process, we can eventually get the result matrix, which is a 3 by 3 matrix. It's easy to observe that the final result matrix has the same row number with the first matrix and the same column number with the second matrix. In general, if we multiply a m by n matrix with a m by k matrix, the result will be a m by k matrix. What if we reverse the order of the matrices? That is to say, we multiply the 2 by 3 matrix to the 3 by 2 matrix. Following the same rule, we get a 2 by 2 matrix as the result. It is totally different with the previous result, which multiplies the same two matrices but just in a different order. We can conclude that matrices multiplication is not commutative, which means matrix A times B does not necessarily equal to B times A. But why is that? We're not going to explain the details in this video, but we will explore the reasons behind the result in our next video. What if we multiply two matrices like in this example, where the first matrix is 3 by 2 and the second matrix is 3 by 3? Actually, the matrices multiplication cannot be performed on such matrices combination, as the column number of the first matrix does not equal to the row number of the second matrix. In this case, dot products of the row vectors in the first matrix with the column vectors in the second matrix cannot be calculated. This is the end of today's video. Thanks for watching, and please subscribe to my channel for more interesting videos.